In this video, we're going to talk about esters. We're going to talk about how you synthesize esters, how you can hydrolyze esters in different conditions. Okay, and we'll move on to do exam-style questions as well. First of all, synthesizing an ester. You can synthesize an ester using an alcohol with carboxylic acid and an acid catalyst, concentrated H2SO4, and you normally have to put reflux with that as well. So if we move over to the side and then we do our example. So our example here is going to start with propanoic acid. So we put propanoic acid here, 1, 2, 3. Okay, and there is your propanoic acid. Now, I am going to put the OH in a slightly different colour. And the reason is because this will create water at the end of it. And I want to show you what parts of it are the water. So if we have the OH here, so there is your OH, that's going to form part of our water. We then add that, and we will add that to ethanol in this case. So ethanol is going to be like this. Okay, and I'm going to do my O there. And I'm going to write the H of the O in purple. So if we look at this, we've got the propanoic acid, we've got ethanol, we've got all of this in white is going to form our ester. So if you're not quite sure what an ester is, we're going to show you in a second. You've got two hydrogens there and the oxygen, they're going to combine together and they're going to create the water. So if I redraw, I just draw these white bits again, but I bond them together. So here is our acid. Okay, and then it's going to go to our O. And then there are two carbons here. So it's going to be, first carbon is there, and then the second carbon is there. And this is an ester. So if you haven't seen this before, an ester group is this group right here. So this group right here. And that is your ester group. Now if I look here, I've still got the OH and the H, and the OH and H are still not part of this molecule, and therefore they are also produced, but they bond together to make H2O. So our full equation is going to be your propanoic acid plus an alcohol, so it's an carboxylic acid plus an alcohol, goes to our ester, and this is our ester group, and then it forms H2O. Now this is a good point to mention condensation reactions again. Okay, so our exam tip, as we've had in other videos, is a condensation reaction is a reaction in which two molecules, there's your two molecules, combine to form a single molecule where a small molecule, often water, in this case it is water, is usually removed, produced. Okay, so there's your water being removed, being produced to produce your ester. Now let's go back to the ester and let's try and name it as well. So we'll name esters as we go through this video, but you name the ester first of all by ending in O8, and then before the O8 you will have your chain, and your chain comes from your carboxylic acid section. So your carboxylic acid was 1, 2, 3, but it was prop, so it will become propan O8. So this basically is telling us we have an ester, and the length of the carboxylic acid was 3, so propan. And then we look at the length of the alcohol, and the length of the alcohol was 2 carbons. So we call that ethyl propanoate. And always naming, we are going to name the alcohol part as a prefix, so it would be ethyl. We're going to name our carboxylic acid part as our stem, our parent chain, okay, which is propan, 3 carbons in this case, and then an ester always ends in O8. So ethyl propanoate. So that is the simplest way in which you make esters, and you can make them as well, don't forget, with our concentrated H2SO4 here and reflux is our full conditions. Okay? And that is how you make an ester. We're now going to synthesize esters using acyl chlorides. Now you can do that with an alcohol and an acyl chloride. You don't need to reflux because acyl chlorides are much more reactive, and therefore this happens at room temperature and pressure. So let's show an example. So the example we're going to do is going to be slightly different to the other ones so we can practice naming. So we have an acyl chloride, and that acyl chloride is going to be like this. Okay, and we have put the acyl chloride in, and again we're going to use some different colours here. Okay, and there's our Cl and there's our acyl chloride. So our acyl chloride is going to be ethanoyl chloride. We're then going to react that with an alcohol, and the alcohol, okay, is going to be propanol. 1, 2, 3. Okay, and then we've got the OH, so this is propan 1-ol. So we can add those two together. Okay, and they're going to make, all you do is take the O, remember there's a lone pair of electrons here, that comes into here, which is delta positive, okay, and that's delta negative. Again, said before in previous videos, that's also delta negative, but this is the bit doing the reaction, and you don't need to know the mechanism, so I'm just trying to show you that this goes into that positive centre. Now, if that is the case, if I bond that O onto where the acyl chloride is, okay, and that acyl chloride, okay, and you can see here is 3 carbons, 3 carbons. You can see 2 carbons, 2 carbons. Right. Now, also, you can see that the H and Cl are not there anymore, so therefore they have been kicked out. And that then goes to our exam tip, which we've used before, but we use it because it is in exam questions and it's really good to know. Condensation reactions, be able to recognise them. It's when 2 molecules are reacting to give out a small molecule such as water. Now, it doesn't have to be water, it can be HCl. Now, just to show you some different namings as well, let's name this. So if we look at this, we're naming our ester. The first thing we need to do is decide what a prefix is. So we do it a slightly different way this time. Prefix, the prefix is the alcohol is prop, so that would be propyl. So that comes from our alcohol, propan 1-ol, propyl, okay. Then we look at the stem, which is 2 carbons, so that would be ethan. And then we know it is an ester, so we end it in O8. So that's propyl ethanoate, okay. So we're going to take ethanoyl chloride, add to propan 1-ol, and make propyl ethanoate. And that is how you make esters using acyl chlorides. The next way of making esters is to make them with acid anhydrides. So acid anhydrides are very similar in reactivity to acyl chlorides, so there's no need to do it at a higher temperature, reflux. You can just add the acid anhydride to the alcohol. So we do an example, and the example we're going to do is going to take something called butanoic anhydride. So we'll do 4 because it's but. 1, 2, 3, 4. 1, 2, 3, 4. And then we're going to make the anhydride. If you're not sure what anhydrides are, they're like 2 carboxylic acids joined together. So if I, again, use my colours, and you can see here 1, 2, 3, 4, 1, 2, 3, 4. Okay, and it's like 2 carboxylic acids joined together. And that's actually how it's made. So basically, they come together with a condensation reaction, they lose water, and they join up making this. Now, it's very unstable. very reactive, okay, and so therefore it will easily react with an alcohol to make an ester. Now let's look at the alcohol that we want to use this time, and we're going to keep it relatively simple, and there is your ethanol. Again, really important with the colours. So in the purple here, you can see what's going to react together. So we can see that this part here is going to react with the H, and this O is going to come in here. Now, it's useful because anhydrides, you don't come across them very often. We'll name this one. So this has two butanoic acids. So essentially what we do is we call butan and then oic, because it's made from carboxylic acid, and anhydride. So that's butanoic anhydride. But don't worry too much about the naming, that's what it's called. And then what we'll do is we will make our product. So that O is going to come into here. Remember we said before in the previous slide that this is delta plus. So that lone pair of electrons from the oxygen will come in and bond into there. And if we redraw, so we've got our 4 carbons there, we've got our O, and that comes down, and this is going to bond to this O here. Okay, and then we've got 2 carbons left to do, which we did. Now here's the interesting thing, is that you don't get your normal kind of small molecule, you get a slightly larger molecule here. So remember, this is in purple, and then react with the H. So what you actually end up getting is you get a carboxylic acid. So really important distinction is that when you do it with anhydrides, you will get the corresponding carboxylic acid made 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Okay, so you'll end up getting butanoic acid. Okay, and you'll also get, and we'll practice naming again, here you've got the alcohol group, which is ethyl, and then you've got 1, 2, 3, 4, okay, which is butan, and then finishing it with O8. Okay, so that is how you make an ester from an acid anhydride, and you will make your ester plus a carboxylic acid.